Hey everyone, this will be a video on section 1.1, which is about functions. I'm going to go through the notes and talk about certain things, highlight certain things. We might not do all the questions in the notes. I'm primarily going to focus on things that you'll see on the homework, and if there's anything that is on the homework that isn't in the notes, I'll talk about that after the notes are over. So we see at the beginning we have some preliminary graphing concepts. So the Cartesian or rectangular coordinate system consists of two real number lines, one that's horizontal and one that's vertical, and those two lines intersect at what we call the origin. The two number lines are called the horizontal axis and the vertical axis. So together they are referred to as the coordinate axis, or axes, I guess. The horizontal axis is usually referred to as the x. Okay, so we usually recall this as the x-axis here, and it's mentioned here. And the vertical is usually the y. So remember, horizontal goes left and right, vertical goes up and down. The coordinate axis divide the plane into four parts called quadrants, which are numbered counterclockwise using Roman numerals 1 to 4, starting in the upper right. So it'll be like 1, 2, 3, and then 4. So we'll label that down in a moment in the example that we're going to talk about. All right, so let's look at this example that we have. So it wants us to label the x and y axis, mark the four quadrants with the correct Roman numerals, locate and mark the point with coordinates, sketch the horizontal line through the point, and sketch a vertical line through that same point. So I'm just going to try to divide it up as evenly as possible. So let's say that we have the x-axis here. And then let's say we have the y-axis here. And let's label our quadrant. So from the top right, it's 1, and then 2, 3, and then 4. And now let's locate the points. Remember, for an ordered pair, it's x comma y. Okay, x is always first, y second. So this tells me from the origin, I'm going to go left to right for x. So if it's positive, I go to the right. If it's negative, I go to the left. So this says I'm going to go right 4 and then down 2. So from the here, 1, 2, 3, 4, down 2. So right here. If I could just make a point, that would be great. All right, and that's 4, 2. Okay. And now I need to make a horizontal line. So remember, that's a line that goes left and right. So this would be your horizontal line. And then we're going to make a vertical line through that same point. Okay. So this is just familiarizing yourself with some of the things that you hopefully recall coming into this class, like plotting points, graphing things on the coordinate plane, the Cartesian plane also, okay? So if we look at the next little piece here, it says the fundamental theorem of analytic geometry. So there is a one-to-one correspondence between the points in a plane and the elements in the set of all the ordered pairs of the real numbers. For each point in the Cartesian coordinate system, it corresponds to exactly one ordered pair of real numbers. And each ordered pair of real numbers corresponds to exactly one point on the Cartesian coordinate system. So what that's saying is, let's say you put a point somewhere. There's only one way you can represent that. You can't say it's this or that or this other way, okay? So that's why that's saying. So if we look at the next part here, a solution to an equation in two variables is an ordered pair of numbers, so an x value and a y value, that when substituted into the equation, we get a true statement, or we get the same value on both sides after we simplify. So let's look at this match problem 1, and then we'll continue from there. So some of this is just reiterating some vocabulary you should have known. So for the match problem 1, the only one I really want to focus on doing is A. We're not going to graph anything as complicated as B in the class ever. So I want to sketch a graph of this. So one method is you just do point by point. So you should recall that from previous math course 115, college algebra, or from high school, that if you want to graph y equals x squared minus 4, that you hopefully recall that since x squared is your highest x power, this is going to look like a quadratic. Right? So I'm going to pick some values and then do the plotting. So I have my Cartesian system here. I'm just counting off. All right. So I want to plot this, so I'm just going to pick some points to plug in. So I'm going to stick around 0, so I'm going to have my little table here, x and y, -2, -1, 0, 1, and 2. Usually these are very common values to pick for your x, and then you plug it in, see what you get, and you might have to pick more if you don't really see the quadratic shape. So remember, the quadratic is like a U, either opening up or opening down. So if I plug in -2 here and simplify, you could use your calculator. -2 squared would be a positive 4. 4 minus 4 would give you a 0. So this would be 4 minus 4 and make it 0. If I check -1, -1 squared minus 4 would be 1 minus 4, which is a -3. I plug in 0, I get -4. Now see if you can get the 1 for 1 and 2. So if you plug in 1 and you square it, you minus 4, you should get a -3. And then the same thing for a positive 2. If you square that, you get 4. 4 minus 4 is 0. Okay. So don't try to get bogged down by the simple calculations. Always check with your calculator, because you'll have that on your test and final. So if I plot these, -2, 0 is right here. -1, -3 is right here. 0, -4 is right here. If I could actually plot the graph, thanks. 1, -3 is right here. And then 2, 0. So if you have to do this on your homework, it might ask you to plot 2 or 3 points and then do the quadratic graph. So you could just plot 2 of these and then do the graph and see what it gives you. Hit the appropriate button. It's going to look something like this. Okay, so we're not going to talk about B. So the next problem won't happen yet, but you'll see that it talks about what we just did, the point-by-point graphing. So this is a process where ordered pairs of points that solve the equation or that are a solution, the points are plotted on the grid and they're connected to make a smooth curve. And we just did that in the prior one. So now let's talk about a function. So a mathematical function is a correspondence between two sets of elements such that each element in the first set, typically we say this is the x values in most of the cases, or the domain, corresponds to one and only one element in the second set, or typically the range, or the y values. So the first set in such a correspondence is called the domain, and then the second one is called the range. So I'm going to draw some examples on the side here of how you could have seen functions before, just different representations. So one representation is as follows. can use a table. So let's say I had domain here. I have 3 values, 0, 1, 5, and then I have the range. And I have only 1 value. So let's say if 2, I get the range for 2. 0 will give me 2. 1 will give me 2. And 5 will give me 2. As is a function. So let's think about the definition. Key concept for functions is the requirement that each element corresponds to one and only one range. So if I look at the domain, is it only going to one range value? Yep, the 0 is good. Is 1 only going to one range value? Yep, it's only going to 2. And 5 is only going to 2. It doesn't matter that the range is repeating or multiple values in the domain are going to the same range. It's just that the domain can't repeat. So this would be a function. Yes. So what about if you had a table, what would not be a function? So if you think about the domain, let's say we had 3 and 4 here as some domain values. And let's say we had the range of 1, 2, 3. Let's say 3 goes to 1, and 3 goes to 2, and then 4 goes to 3. So you'll notice this is not a function. So not function. And why is that? Well, right here, each domain corresponds to one and only one. But we notice that the 3, what is happening to it? The 3 here is going to 1, but it's also going to 2. So that is not a function. Because it's kind of ambiguous. Well, if I have 3, well, what would be my range value? You don't really know. You know it can be either 1. So it's kind of unclear. So that's why it's not a function. Your domain can only be linked or only go to one range value, and that's it. Okay. So let's say if we had a table, this is how we could tell. All right. Another way to tell is if you have an equation. So if an equation in 2 variables, if we get exactly one output for each input, then the equation specifies a function. And then we could graph of such a function is just the graph of the equation. If you get more than one output for a given input, the equation is not a function. So we'll look at some examples of this. So we have this here. And we have it already graphed right here below us. So sometimes on your homework, you might just have the equation like here. Or you might have a graph. And it will ask you, is this a function or not? Well, this example is a function, this first one here. Okay? Because if I think about any value I plug in, so it says y is a function of x. So this means that y is being determined by those x values. So y would be your output or your range, and x would be your input or your domain. Okay. So if you solve this for y, you get, if we add over the x squared, y equals x squared plus 5. So you notice that for whatever you get for x, you're going to plug it in, square it, add 5, and get the y. You're not going to get 2 y values, you're only going to get 1. So whatever you plug in, each domain is only going to have one range. So that's why that specifies a function from the equation. Okay. And later we'll see how can we determine that if we just had a graph. So if we look at the next piece, we see that this would not be a function. And why? Why do you notice is different about the equation? Well, you see this is actually y squared. So if you recall from your college algebra or previous mathematical experiences, y squared, if I solve this for y, would equal x plus 5. And then to get rid of this squared here, I have to do the square root. So that would be plus or minus square root of x plus 5. So for whatever value I want to plug in for x, I would add 5 first, then take the square root, but then I would have to put a plus as one value and then a minus. So whatever value I plug in, it looks like I'm getting two different outputs from this plus or minus here. So that's why this is not a function. Because remember, every domain or x value I plug in only can give me one y value. It can't give me two. Okay? So let's kind of summarize this. And here's a graph of that. Why is it not a function? Okay. So now let's summarize and practice. So we see the first part here, determine whether it's a function or not. Well, we automatically see that y is squared. So from our previous experience, this would not be a function. And you want to think, why is it not? Because y is squared? Because when you solve for y, what's going to happen? You're going to do a square root, you're going to get plus or minus. Okay. The next one, we see y is not squared. So it looks like if we solved this, it should be okay. So is this a function? Yes. And this would be a function because y is to the first power. Okay. Or if you solve this, you add over the 2x first, and then divide by 3. So y equals 2 over 3x plus 3 over 3, which I can say is y equals 2/3 x plus 1. So it seems like I'm okay. Whatever I plug in for x, I'm going to multiply by 2/3, add 1, and that's going to be, so every x corresponds to only one y value. So let's say we didn't have a graph, and I wanted to, we didn't have an equation and we only had a graph. How could I determine if it's a function? We'll see down here, we already see the theorem that we're going to use, which is the vertical line test for a function. So an equation specifies a function if each vertical line in the coordinate system passes through only one point or nothing. If a vertical line passes through two or more on a graph, then it is not a function. So you can look back earlier, that first graph that we had that had something like this. What did it look like? It was like this. This we said was a function. Okay. But then the second one, which looked like this, we said is not. And why is that? So if you draw a vertical line anywhere, it's only hitting my graph once over here, so it's okay. Just once. But over here, if I start drawing, it's not hitting it, which is fine. But what happens when I get to my graph? It's hitting it twice. And this is bad. So that means it's not a function because that vertical line is hitting it twice. Okay, that means that for one x value, I have two different y values that go with that. So that's not a function. So now we're going to get into some more vocabulary, independent and dependent variables. So input values for functions are domain values and output values are range values. Functions, which are function equations, are often use the variable x as the domain and y as the range. The input variable is called the independent variable and the output is called the dependent because the output depends on the input. Okay, so that's why we have that. If a function is specified by an equation and the domain is not indicated, we assume it's all real numbers. The independent variable is the domain values, and the dependent variable represents the range values. The range values are all the possible outputs we can get from any of the inputs. Okay. So let's look at the following example. We have this. Find the domain of the function. So recall a square root, right? So square root, I can't take the square root of a negative. So square root, so what's in here can't be negative. So x minus 2 has to be greater than or equal to 0. So I solve this for x, add over 2. So x is greater than or equal to 2. So that's my domain. So that would be bracket 2 to infinity. This is interval notation. Right? Another one that we could do for this, what would be the domain? Another popular one is a rational function. So suppose you had y equals, so this is like extra, y equals 1 over x minus 3. Remember, we can't divide by 0. So can't divide by 0. So then the domain would be any x value I could plug in except for what would make it 0. So x minus 3 cannot equal 0. So I add 3 to both sides. And I get that x cannot equal 3. So for this one, the domain would be everything except for 3. So that would be negative infinity to 3, union 3 to infinity. So try to recall your interval notation from your previous math courses or from 115. Okay, so let's look at the next topic, which is function notation. Function notation gives an alternate method for naming functions so that the correspondence between a specific input and output values can be easily shown. Letters are typically used to name functions specified by equations. So for the first example, we see that we have y equals 2x plus 1. To write this in function notation, instead of y, we write f of x equals 2x plus 1. And this is the f function. You could use any letter you want. Typically, they use this naming system. If you have a lot of equations you're dealing with, you don't want to say equation 1, equation 2, equation 3. You can say the equation for this or the equation for that. It keeps it a little bit cleaner. So now we're going to use function notation to do some evaluating. So we have 3 things here. We have that f of x is right here. Ooh. Zoomed in a little too much there. We have f of x is here. We have g of x and h of x. So for the first one, it wants f of negative 2. So I need to think, what is f? Well, f of x is 12 over x minus 2. So what I need to do is plug in, instead of x here, I need to plug in the x value I'm going to use, which is negative 2. So this would equal 12 over negative 2 minus 2. So that would be 12 over negative 4. Usual order of operations, so I did the subtraction down there because it's when you have a ratio, you always simplify the top and then simplify the bottom and then you divide them. So this would be negative 3. So f of negative 2 is negative 3. So let's look at b. G of negative 1. So I'm going to use my g function. So this would equal 1 minus x, which is negative 1 squared. So this equals 1 minus 1, which is 0. So g of negative 1 is 0. See here, we want to find h of negative 8, so we go to our h function, which is square root of x minus 1. So I'm going to do my square root here. And instead of x, I'm going to put what the x value is, which is negative 8. So I get square root of negative 9. And I can't simplify that. We're not dealing with imaginary numbers in this course. So we'd say there's no solution to this. Okay. Now for D, what you need to do is you want to find f of 3 first, find h of 5, and then divide them. So f of 3 will be 12 over 3 minus 2, which is 12 over 1, which is 12. And then h of 5 will be square root of 5 minus 1, which is the square root of 4, which is a 2. Now it's not plus or minus because the square root is already there. So we can assume it's positive. So we have f of 3, which is 12, so that would go on top. Without the f anymore, because we already said that f of 3 is 12, so we don't have to write that at all. H of 5 is 2, so this would be a 6. Okay. And now the next part is practicing some domain questions. Okay, so take a moment, see if you can answer these 3 about domain. What is the domain of f? What is the domain of g? And what is the domain of h? So use your notes. Okay, so you could pause the video if you want to try this on your own. So for f, the domain would be all reals. So, which would be negative infinity to infinity, and this is called, this is a polynomial function. Okay. The next one, you see we have a rational function, and we can't divide by 0. So if you set it up correctly, you'll get that x cannot equal negative 3. So then that would be negative infinity to negative 3 union negative 3 to infinity. And then the last one, you get that x has to be less than or equal to 2. So how do you get that? I'll do the interval notation first. You would say that, remember, 2 minus x, what's underneath the square root has to be strictly positive or non-negative. Okay, so that will be this, and then I want to solve for x. So if I add over x, I get 2 is greater than or equal to x. So I'm going to rewrite it where x is first. Remember, that means the inequality sign is pointing to x. So x is, this is writing it the other way. So I get x is less than or equal to 2. Okay. So you can't change x and 2. The inequality won't stay the same. You have to transition it when you move. So the difference quotient is the next thing we'll talk about. So the difference quotient is the following here. You have, if you want difference quotient for x and x plus h in the domain of f, you would have f of x plus h minus f of x all divided by h. The difference quotient finds the slope of a line between 2 points on the graph of a function. Okay, so we're just going to use this to help us get the match problem. So first thing I want to do is I want to find f of a. Alright, so for f of a, well, that's just going to be f of x, but for x's, I'm going to put an a. So this will be a squared minus 4a plus 9. Now for the next one here, I want f of a plus h. So that's going to be, for all the x's, I plug in the expression a plus h. Okay, so that will be, I plug in a plus h for that first x, so it'll be a plus h all squared, minus 4 times a plus h, plus 9. So I'm going to simplify this a little bit. So off to the side here, a plus h times a plus h will be a squared plus ah plus ah. So first, outer, inner, last. So that'd be h squared. I did the foiling technique. You could also do the box method. So this first piece will be a squared plus 2ah plus h squared. The second one here, I'm just going to distribute, so minus 4a minus 4h, and then plus 9. You see, nothing will combine. Okay. So for part C, so I need to make sure I write this down. Okay. So for part C, what do I have? Part C says I need to subtract the two. Okay. So for C, I need to subtract them. So that would be a squared plus 2ah plus h squared minus 4a minus 4h plus 9 minus f of a, which was a squared minus 4a plus 9. So what's going to cancel out? Well, a squared minus a squared, negative 4a minus a negative 4a, and then 9 minus 9. So what's only left is these three terms. So 2ah plus h squared minus 4h. And then it says for part D, I need to take what I get and divide it by h. So 2ah plus h squared minus 4h all over h. So how would I do that? So I need to do it for each piece. So 2ah over h plus h squared over h minus 4h over h. So now I'll simplify it. So these h's cross out and I get 2a. These will cross out and I get minus 4 at the end. H squared over h will cancel out and leave me just a h left. So now the last part of the notes talk about applied word problems, applications. So we have some terminology here. So profit loss analysis. Companies use profit loss analysis to support decisions regarding the pricing of products and appropriate levels of production to maximize the company's profit. A manufacturing company has costs C, which include fixed costs and variable costs. So fixed is something that's going to pretty much stay the same. The variable cost will depend on how much you produce. The revenue of the company is the amount of money it receives from selling its product. And then profit is revenue minus cost. So all these are very critical concepts. Right? And right here, if revenue is less than cost, so I'm not bringing in enough money to make up for my cost, I'm losing money. If the revenue equals the cost, I'm breaking even. Okay, I'm not losing or gaining money, or making a profit, I should say. If the revenue is greater than the cost, I'm making a profit. So a price-demand function specifies the relationship between the demand for a product X and the price of the product P. Okay. So price demand will tell me what would the demand for a product be, X, for its price, P. So the coordinates XP are the solutions to the price demand, and we can write P of X, so tiny P of X, at which X items are sold. So suppose the price of a popular item is reduced. Do you think the company will sell more or fewer? If you have an example, use it to explain your answer. So if you think about it, just with anything, if the price is going down, you're probably going to have a higher demand. More people can buy it. Okay? So companies that use the price demand function, tiny p of x, that specifies the relationship between the demand of a product, X, and the price of a product, tiny p, to examine pricing of their product. So generally, a reduction in price results in an increase in the demand. Thus, the graph of a price-demand function is expected to go downhill as price increases from left to right. Okay. So what this means, if you had your P of X equation here, and this is your X, which is the amount you're going to sell, and you have your P, which is the price. What it's saying here is if when the price is really high, your amount's going to be really low. But as you would sell more as the price goes down. So it's going to look something like this. So you're selling a lot because the price is really small, right? Because it corresponds to a small value for P. Okay. So you think of it like this. And you can also think the slope is negative, so that means they're kind of opposite of each other. That if the demand is increasing or you're selling more, doesn't mean the price is going up per item. The probably price per item is going to decrease, and vice versa. Okay. So one thing to note here is that the revenue is equal to the number of items sold multiplied by their price per item. So R equals X times P, and we can think that's a tiny P of X. Okay? So if we look at the next thing here, cost, revenue, and so we have some equations. So you have I'm just going to point out some important things here. Cost is made up of fixed and variable costs. See, variable is with your X. Cost is not. The price demand typically is in this format. And the revenue is X times P. Okay, which equals X times your P of X equation. And your profit, as we said earlier, large P is revenue minus cost. So let's look at an example at the bottom. It says a company sells notebooks. So write down this equation, or if you have your notes printed out, it's there for you. We want to find the expression of the company's revenue and find the domain. Well, earlier we said that revenue was, if you recall, X times P, which is the tiny P of X, which would equal X times, well, we have an equation for P of X here. 2,000 minus 60X, which if I distribute that X, I get 2,000X minus 60X squared. So that would be my company's revenue function, and I want to know what's the domain. Well, if we see here, it says the domain is from 1 to 25 in terms of thousands. So the domain for the revenue is going to be the same domain as the price demand equation. Because you want to think, why is that? Well, the price demand creates the revenue. So if the inputs for the price demand are a certain values from 1 to 25, the revenue has to be the same because the price demand has created the revenue function, and that's why. So my domain would be when you go from 1 to 25. So that would be bracket 1, comma 25 bracket. Okay. And now we're going to look at 2 of the homework questions that I will pull up on here. Just give me just 1 second. All right, so this is question number 15 in your homework. So I'm going to go over this one. I'm going to write things off to the right side that might be hard to see. So we see that I have the revenue, which is 75x minus 3x squared, and it gives me the domain is 1 to 20, including them. And then it says my cost is 120 plus 15x. So what it wants to know is what's the profit. So remember, profit is, so this is big P of x, it's revenue minus cost. So I need to do the revenue minus the cost, so 75x minus 3x squared minus, parentheses, 120 plus 15x. So I'm going to distribute, so minus 120 minus 15x. So the 75x minus 3x squared comes down. And now I want to combine like terms. So what will happen here is that the 75x and the 15 will combine together. So this will be 60x minus 3x squared minus 120. And this is what I get for my profit. Okay. So I'm going to type that in. You won't see my writing because I need to type now. So we said that was, let me see, 60. All right, so I've typed it in here, 60x minus 3x squared minus 120. Now what I want us to do is what's the domain of the profit. So as we said before, anything that we use to build another function, it has to keep the same domain. So if the revenue and cost are both 1 to 20, the profit has to be the same domain from 1 to 20. And then now I just need to fill out a table. So if x is 1, that's my profit. So what I need to do is I need to use the equation I have for part A, use my calculator, plug in certain x values, and see what I would get in the end. Okay. So you want to take each one, plug in those x values that you get to answer those, and then you're going to plot them for the last part. So if you do have any trouble with doing part B or later, shoot me an email and I'll be glad to help you. Okay. So the other one we're going to look at from the homework is this one. So I'm going to zoom this in just a little bit. All right. So this says perimeter of a rectangle is 240 meters. So we have a rectangle that's 240. So perimeter is 240. Express the area as a function of L. So area with some stuff with L only. So currently, if you think area for a rectangle is length times width. Well, I only want the length, not the length and the width. So what I need to do is get rid of W. But how can I do that? Well, if I know the perimeter is 240, And recall perimeter is 2L plus 2W. I can solve for W for using the perimeter and substitute that in for the area. So if 240 equals 2L plus 2W, solve for W here because I want to get rid of it in the area. So 240 minus 2L equals 2W, divided by 2. So 120 minus L equals W. So area would equal L times parentheses 120 minus L. Okay. Now before we enter that in, we want to think, well, what would be the domain of your thing here? So if you think about it, if the perimeter is 240, well, the smallest it can be is you don't even have a length, so 0. Okay, and then the largest it can be, well, it can't be 240 because then you won't have technically 2 lengths because you need a length on both sides. So the highest will be half of that, which is 120. And you want to think, you can't have equal those values or else you won't have a rectangle. You'll have just like a slab, just a straight line. So we're going to put parentheses around these. So that would be your domain. Okay, so let's type these in. So this would be, we said L parentheses 120 minus L. And then the domain is from 0 to 120. Okay. So I hope you enjoyed the first section here. Send me an email if you have any questions. I'll be more than happy to help you, and I will post anything on the discussion board. Thanks again for your time.